Hi, so recently I have been working a lot with this Gladiator arena environment, and while I was optimizing it, I realized that this would actually be a real nice level for people to practice optimizing their assets, meshes, and textures because of the few things. So first, everything is kind of unoptimized. The assets are good enough that even in the unoptimized stage, it is still running at around 100 FPS for me, which is not too bad, but there is a lot of stuff that could be optimized. So for example, none of the meshes are instanced in this level. Also, let's go to LODs. If you're not familiar, this gray look means that this object is at the highest level of detail for the mesh, and red means level 1, and then green level 2. So if we zoom around, you can see how to get to the level 1 or level 2 LOD, you have to go really far, but the player is never going to see this level from this perspective, which means that when we are at the actual ground level, the LODs are almost unused here. There is a lot of stuff like this that is unoptimized in this level, so I thought it would actually be a really nice level for people to practice, and we're going to go more into it. I'm going to show you my level. Because I was using this, I was optimizing it. I have a version where I did some basic optimization. It's not done, but I was optimizing a bunch of stuff, and I wanted to show you different ways that you can optimize your level. So we looked at LODs, we looked at instances, and there is also textures and some other stuff that you're going to look at and how to optimize it. But before we go, I want to mention that this Gladiator Arena environment, I think it was some like free for the month event, and that's how I got it, because I don't remember buying it ever. But if you want to buy it, I think it's $50, which is a decent amount. So if you don't have this environment, I found that most asset packs are usually created with a hard fidelity and not really that optimized. So I think you can easily find similar type environments that you can use for optimizing stuff. Okay, so now that we know that, let's first go over how you can even figure out how optimized or unoptimized your level is. First things first, we can see here the frame rate in the level. Now, this can help you to get a general idea of how intense this level is, but it can be a bit misleading because there is multiple things that can be a bottleneck to your final frame rate. For example, your CPU could be bottlenecked, maybe you don't have a lot of RAM, so maybe there is some issues with gathering assets. There could also be stuff on the GPU. So just looking at the FPS doesn't really tell you if your level is the issue, or if the amount of meshes in the level is the issue, or maybe the size of texture, stuff like that. So it doesn't really tell you that. It just tells you your final output of the FPS. So first things first, we need to just get some data so we have something to compare to after we try optimizing. One easy thing that you can do is type stat detailed in the console, and this is going to bring up some basic information about frame rate and different threads and what is being executed. For example, this is our final frame rate, but in here we have different threads. You can have your main game thread that deals with what is happening in your game, and then you maybe have GPU thread or RHI thread that deal with different stuff. So in here we can see a few things. First, we see our draw calls, how many primitives, so how many millions of triangles we have. We also have our RHI and GPU threads, which tells us generally how much it costs to graphically render this. So let me then bring you to my level that I was working on, and the lighting and stuff like that is way different because I was going more for over the top sun, so it's a little bit different. But if you look in here, for example, we can see that now we have a little bit less draw calls and way less primitives. So if I even go around, you can see how it holds around 800,000, while before, if you go to demo, you can see how we had way more triangles to render and also more draw calls, meaning more individual objects and materials and stuff like that. So if I go back here, you can see how in here usually we have around 1,000 maybe. And you can also see for our RHI and GPU time threads how they are way lower. So they are around 5 to 6, while in the demo we had around 8, maybe 9 for GPU time depending, and 7 for RHI thread. So this is how you can get a bit more information about what is happening in your frame. You can also see some memory stuff. Now I haven't in my level almost at all touched memory, meaning like texture size and stuff like that. There is some optimizations for meshes that I did, but not that much. So this is the level 1 of figuring out what's happening with our level. Another thing that we can do is the thing we did before, where we go to our LODs and we can see how most of the things are at the highest density regarding to meshes. And if you go to my Arena 1, I did some optimizations here, so you can see if I'm standing in the middle, there is way more stuff that are now lower resolution, even at level 2 LODs, which is one of the lowest that I use in here. And you can see if I move around and I move maybe in this corner, you can see how way more stuff now is lower resolution, and that means means that there is going to be less primitives and maybe less stuff to draw. So also these LODs you can use and say for materials on the meshes to not cast shadows and stuff like that. So you can optimize even more stuff. And you can see here how our draw and RHI thread are going lower and GPU thread going to 3 because we are basically loading lower resolution meshes in the distance. So there is less calculations, if that makes sense. This is another way to analyze and see what is happening in the level. Okay, so we have our LOD view. Now, third way that we can figure out what's happening in our level is, let's go to demonstration and let's disable stat detailed, or actually stat unit to disable it. Also, another thing, you don't have to type in the console if you don't want. You can also go to stat in here and then engine, and you can have stuff in here. It's just usually a bit easier to just type in the console. Okay, so the third thing, how we can figure out some resources that are used in the level are audit and then statistics. There's many different tools. I'm just going to show you a few that I found useful, but if you don't find them useful, then that's fine. You have different stuff. So in here, let's first start with the primitive stats. So this is going to show you in your level, for example, how many objects are in the level, how many actors. We can even, let's do actually count. For example, a lot of our wood in the level is just individually counted. It's not instanced, but you can see different stats regarding all of your meshes in the level. In here, we can also go to texture stats. And for example, see in here, if you look at max dimensions, we can see that there is a bunch of meshes in this level that are 4K. And the question is, do they really need to be 4K? So for example, when I'm optimizing a level like this, what I'm thinking about is what is the player's playable area. So for my project, the player cannot go above these boundaries. So he can just be inside of this arena. So that means if any of these objects, if I zoom in here, maybe like this object, all of this detail that is happening here is completely unnecessary. The player is never going to look even close there. So my worst case scenario is maybe player is somewhere in here, let's say here. And if I look at this object, it's decently far away that I don't have to use anything high resolution. If we zoom in here, we can see how much detail we have in here, but all of that is completely unnecessary. I could probably slash the texture of these types of objects that are a little bit more in the distance I'm not going to use by probably 70 to 80%, and I'm not going to notice the difference, or the player is not going to notice the difference. So then what you can do is click the texture in here. I can go to that specific texture and we can change the size. So for example, I can do in here max texture size and I can put it to whatever. You can also downscale it here if you want for different platforms, and also you can do some optimizations like compression and stuff like that, but for now you should just think about the general size of the texture. Also, if you're interested in who is using this texture, what you can do is right click and then reference viewer, and in here I usually increase the depth, and then we can see these bricks is used by MI brick, and then MI brick is used on these 4 objects. So it's used for all of these meshes, which player can actually come really close to. So maybe for these objects, you do want it a little bit hard. Actually, now 4K might be a bit too much, especially for something like albedo. I'm not sure which objects are in here 4K, but maybe 248 or something like that for something closer like this. But then if we go to something like this object, we can probably go with 512 by 512 or something, and it will be good enough. The player will not notice at all the difference. Okay, so those are the main things. And the third thing I'm going to mention is, let's close this, is this trace. There is a useful tool called Unreal Insights where you can trace your frames while you are playing or just in editor, and then you can analyze each frame and check what is happening and see what are your bottlenecks, what is taking a long time to process. What you can do in here is, if I press play and let me click start tracing, and I'm gonna stop tracing, so you just trace for maybe a second and go to trace here, we can see recent traces. You can check by time if you are unsure which one of these. It's usually just at the top, but it's 3:59 for me, so I know that this is my time. Now I'm not gonna open that one. I'm gonna open 2 other traces because I'll already traced both my level and the original demo level. And in here we have 249 is my level, and then we have 248 for their demo level. And what you can do in here is, this is my maybe 1 second of gameplay or 1 to 2 seconds of gameplay, and you can zoom in to individual frames, and basically if I look in here, you can see in here similar chunks, and that's basically frames. And if you zoom in, you can see what is happening for each thread, for each frame. Now it's a little bit tough to see. I had to do half and half of the screen so you can see both versions, but also we can close this, move it. And then here we have your game thread, we have RHI thread and render thread and bunch of background and worker threads that can do a bunch of stuff. So most of the modern CPUs are gonna have multiple cores. So if I click Control Shift and Escape on my PC and go to performance, you can see how my CPU has 12 cores and 24 logical processors. What game engines are going to do is try to utilize as much of your CPU as possible to do a bunch of different stuff. And there is also threads that are created for different processes to do their things. So in here, what you're going to do is check out our render thread to see what's happening. So I'm going to zoom out a bit. Let's see what frame we're going to pick. So something in here maybe. Let's go down, let's go to render thread, and let's see specific frame and what's happening inside of it. So for my render thread, it takes about almost 10 milliseconds. So that's around 100 frames a second for this specific frame. And we can see that there is wait for tasks, which means that this time was taken up by just this thread waiting for someone else to do something. And then we have the actual work of this render thread. So you can see this task above, it basically consists of all of the little tasks that needed to be done, and then that encapsulates this one thing. So let's do similar thing in here. I'm going to go to a frame, and you can see we're doing the same thing. Let's find something like this. Let's zoom in and let's see what's happening. So now that we have a frame, we can see that the total frame time is pretty similar. But if you look at our shading scene renderer, we can see that there is 3.4 milliseconds for my level, and then for this is 4.4. That is about 25-30% difference. And if you look at each other frames, so 3.9, 3.7, 4.8, and I go in here and look at the frames, so 3.8, 3.6, 4.1, 3.2, 0.6, 3 milliseconds. And let's go here. So 3.7, 3.9, 4.4, 4.3, 4, 3.7. So it seems like the original level was hovering around 3.5 to 4 milliseconds, while mine is doing a little bit better, around 3 milliseconds, depending on the frame. There is a bit more waiting for my level. That basically means that there is a bottleneck somewhere else. So I'm not going to get a huge performance increase, which when I was testing, I was getting probably around 10 frames a second more for the few optimizations that I did. So what I would do next is check what are these waits and what is the bottleneck, what is making my render thread waiting, because if I fix that, I would probably increase the execution of the render frame by 2 or something similar. I could probably slash it as 5 or 6 milliseconds for the total render frame if I figure out what is this huge wait. But this is another way that you can figure out what is happening in your game. You can basically look at your threads and see what is actually executing. Okay, so now that we know that, let's go through a few ways that you can optimize your level. First things, we have instancing. For example, if I look in this level, in their demonstration level, everything is separated, meaning these doors, even though they are basically the same mesh, they're all rendering individually, which takes longer than if you batch them together. And you can see they're grouped together, but grouping them together just makes it easier for you to move them around, but doesn't actually do any performance optimizations. So what we could do in here, we can select it, go to actor, then merge actors. I'm going to go to merge actor settings, and in here we can batch them together. And what we can select here is few properties. You can choose if you want instant static mesh, hierarchical instant static mesh, and you're gonna go over that soon to tell you basically what is the difference between these. There is also grass and stuff like that, but for most things you're gonna use these two, and you can click on merge actors. So I'm going to also delete the previous actors because you don't need them, they're just separated right now. So I'm going to press yes, and in here now they're merged together. So if I click on actor 1 here, what happened is that under for you created an actor, it created this instance mesh component, and if you scroll down we can see these instances, and then each of these individual instances is one of these objects. So now that they are merged together, and what that means is that they're all rendering the same batch, and that's going to help with performance. Of course, you don't want to combine like just 2 objects or something like that, you want to have multiple of them. But yes, so let's now go to Arena 1 and look at a few examples of objects that I already batched together. So we have similar thing in here. I have my instances, and these are the objects that I connected together. So let's do something better. Door frames, this is a good one. So I combined all of this together because usually when you're standing around them, it's fine for all of them to load, and we basically batched together 48 objects. Now there is pros and cons to batching stuff together like this, and one con is that even for example, if my character is standing like this and we just see a little edge of this object, it's going to load everything. But because we batch it together, loading everything is actually really cheap, so it's not that big of a deal. And usually if players are running around, I'm completely fine with loading all of this. Now, if you go to our level of detail and go to mesh, So I'm going to find the best object here. We have these rocks, for example. You can see how these rocks are not becoming red or going to lower LOD, even though some rocks in the front are. And the reason for this is because when you create instances of an object and create this instance static mesh component, that basically means that now they're all taken together to figure out what the LODs should be. They cannot individually change LODs unless you have hierarchical instance static mesh. For example, this debris stones pile. If I look in here, you can see how even though they're all grouped together, if I zoom in, you can see how the ones in the back activate their LOD transition earlier than the ones in the front. And that is the advantage of hierarchical LODs, is that they have separate LODs for each object. If I had to guess, that probably brings some overhead. But if you have a bunch of objects like this in a larger area, you probably want LODs to separately load. So it is nice thing to have. Also, you can force LODs. So for example, I know that my character is never going to come to this object in here. I actually forced the LOD1 in there and made it pretty low poly count. So you can see how even though I'm coming closer, it doesn't change LODs. You can see similar thing on these pillars. These pillars are different than the pillars in here. So you can see how they are always at a lower LOD. There is some stuff that do not even need optimizations like LODs. And that is, for example, this object in here, because it is such a low poly count, I think it's 40 or something. If I zoom out and change it, let's say all this from 40 to 20, there is gonna be effectively no difference to that, and I'm just having another object that needs to be loaded in the memory, so the optimization there is completely unnecessary. Now, there is some other things I still haven't gone to optimizing, which is, for example, floors and stuff like that. Also, these places in here are not optimized. But you can generally see what is happening with the LODs. Another optimizations that we can talk about is these packaged level actors. So for example, if I select, let's say, these two objects, what I could do is right click and then click level and then create package level actor. And what that basically does, I guess we can showcase it in here. Let's press OK. Let's save in the content browser. Save it also in here. So basically what we created is this actor that is actually a combination of these objects that are automatically optimized. So Unreal automatically creates these HLODs and a list of bunch of stuff. So for example, if I open up my object in here, you can see a bunch of instance static meshes. Now I didn't bother optimizing this much, but you could remove some of the actors in here because there is probably some objects that are singular in this list that are set as instance. There is more stuff that can be done here, but if you look, for example, in here, this one is just a singular object, so we would probably remove that from this list, but it automatically tries to group stuff together for you, and then you can duplicate it and put it multiple places in the level. So for example, I have it also in here. So these two objects are the same, and you can also double click on this object on the mesh and you can move it around or customize it if you want, because it's another instance in the level basically. Now that we talked about LODs, I'm just going to also open up, let's say, an object here. How you would work with LODs is in here. So we can have different levels and you can define those levels in here. So I can say how many numbers of LODs. I can also choose an LOD group and Unreal can automatically generate stuff for me. For these smaller levels, you probably want to take control of stuff. If you go back here, if they were optimizing it, I wouldn't be able to do these transitions. The transition would need way more distance. But for example, you can see here we're already at LOD2 for these objects. And if you went to their demonstration level, this would not be. This would be the highest resolution, even though we technically don't need it at this distance. You selected in here a number of LODs. Now you're going to have the list in here. And what you can do is say, for the LOD0, what opt enabled for the materials, what screen size does it need to be to transition to this LOD? And since this is LOD0, the highest level, just whenever it's the full size, so this is kind of a default. And you also have this plus if you want for different platforms, different resolution, different options. You have percent triangles. This basically means you want to create lower level representation of this mesh for different LODs. So let's go to level 1. You can see what I set in here is that we need to be at 0.8 of the screen size. So that is probably about this. Let's see. We have a current screen size, so you can check it out in here. So around here, we are basically transitioning to LOD1. And if we check LOD2, we need to be at 0.6, so 0.6 is around here. So that's how quick we basically change from 0 to 2 for the LOD. And we have percentage triangles, meaning that LOD2 is going to be 10% of the LOD0. So if you look at here, it says 1.6k triangles. And if you go to LOD0, it says 16k triangles. Also, one thing if we look at the materials, so you can see how I disabled some options for this material. For some of them, I also disabled cast shadows. Now, because these objects are really big and easily can catch the sun, I don't want to ever, even if I'm here and then this object is here, it's still going to cast some pretty obvious shadows, so I don't want to disable that at this level of detail. But for some objects in here, I disabled LODs, or I think maybe objects like this. I think I disabled, let me see. So you can see I disabled cast shadows because I have mainly overhead shadows, meaning the shadows are going to go from the top, so they're going to be maybe at a little bit of an angle, but these objects are never going to cast any shadow in here, so nothing is going to happen here, especially since they cannot be hit by the sun from these walls. So that is the reason why I decided at level 2 we can disable. I'm not sure if level 1 has them enabled or not. Okay, so it does have some shadows level 1. So all of those options you can enable, disable in there. Okay, and the third thing, I think we covered it a little bit, but we can do a bit more, is go to Audit, Statistics, and check textures, so you can change the scale of the textures, the scale and compression of textures. I will basically go over some textures and see if they are really necessary to be at the resolutions that they are, especially 4K, that is pretty big, but you also need to pay attention to the current dimensions. So for some of them, they're already changed, so treasures, the actual dimension is 512, even if they have 4K texturing here. So you can also check the current dimension if you want to know the actual size, basically. Another thing that you can think about is how many materials the meshes have. So if I take this column, you can see it has 3 materials, but maybe for your use case, you don't actually need 3 materials for this one object. There is no easy way to merge materials. There is some options with these merge actors. You also have simplify, which I think merges materials. I think you can merge into one material, stuff like that. So there is probably some options. I haven't used them much, so I cannot recommend or not recommend. But in this specific environment pack, there is a lot of objects there. It's kind of modularly created, so there is a lot of objects with a bunch of materials that are probably unnecessary. For example, for this material, it's just stairs. I'm not even sure why to have 5 materials. At most, it's 2 materials, but probably just 1 material. Simplifying these types of objects can reduce the draw calls. It won't affect the triangle count, how many materials we have, but having to load each frame, each material is going to cost a bit, so you can decrease the size of that also. So let's disable that. I think I need a unit here. In general, I think that's about it that I wanted to cover. A lot of things, specifically in this environment pack, are kind of unoptimized, and I think it's a really good way for you to learn optimization and see how you can squeeze out as much performance. And I wouldn't focus too much on this frame rate count, just because there is more to the frame rate than just your level. There is probably some other bottleneck, but also you need to think about stuff like nanite and lumen. So in this level, lumen is activated, but nanite is disabled. And I disabled nanite specifically because I wanted to get a little bit higher frame rates, because nanite is really good for high detail objects and levels that are unoptimized. It can kind of bring your FPS a little bit, but there is a base cost for nanite. And if I don't want those, I think it's 2 to 4 millisecond cost for nanite. I forgot. Maybe they decreased it to 1 to 2 milliseconds. But if I optimize my assets decently enough, I should get a higher frame rate than nanite. Nanite does these optimizations for you, or try to do them for you, but there is some overhead to that. If you manually optimize, depending on the size of your level, what you want to do, you could probably do a little bit better optimizations than just enable nanite and getting some frame rate for free. Oh yeah, so also before we end, one last thing that you could use is H-lots. So you can click on hierarchical LODs here, and you can generate clusters in your level and basically say, can you automatically try to merge some assets together, proxy assets. So it's going to say, in this area, pick of all of these similar objects and just merge them together. It's going to do for a bunch of areas, and this can also help you. So you can generate and then generate proxy meshes that are going to be loaded at certain distances. You can have some options in here also if you want to play around. But yeah, so hopefully this helped you a little bit understand how stuff works. And before I end it, one last thing. When you're optimizing, there is 2 main things I think you need to think about that's going to apply for most things when it comes to optimization. One is caching, meaning how much stuff can you do up front so you don't have to do it at runtime. So you want to decrease the things that you will have to do each frame. And also batching, which basically says, let's do all of these things together because it's going to be way faster than individually doing it. So that would be like instancing and stuff like that. So what you want to do is basically make the software do all these things as possible in the fastest way possible. Your level is always going to be the fastest with no object in it, nothing to basically render or figure out. So the more thing you add, you want to add it in more optimized way, meaning what is the least amount of CPU and GPU and memory does this thing need to do to represent the object that I want in my level. So that's about it. Hopefully it helped. And if you have any questions, you can ask me on Discord or leave a message on YouTube.